We've got a couple of people to bring in.
Nelson, Sean was saying we got over 200 people on it.
We'll see how many actually log in, but
that could be.
It should be a good sized group today.
Now, is that mostly that's all just Illinois, right?
Mm-hmm.
Okay.
As far as I know.
Now, when they registered, do you get a breakdown whether they're code official, architect, or engineer?
I believe we do, yeah. And we generally analyze that probably after the presentation. If you're interested, we can kind of pass that back to you.
Yeah, if you could put that on, I'd like to know that. Now, will you guys be into the Energy Council this year for the meetings? Will you be in attendance from
Sure.
SEDAC?
Some people from our office may be trying to get involved. I know a couple of us have IECC memberships that we've signed up for to try to keep in the loop on things.
We actually had IEMA. I forget the gentleman's name. He sat alongside me for the couple of ones we had last year before almost. It's been a while.
Mm-hmm. Good afternoon, everyone. Thank you for joining us. We'll be getting started here in a few minutes, right at 12 o'clock.
Steve Kitaya, he's from Oak Park. He says he thinks I'm on the moon. Certainly am. Well, Nelson has his mic suit down there, and I will mute mine also.
right, good afternoon, everyone. We'll be getting started in just a few more minutes here, getting a chance for everyone to log into our session. We'll be starting promptly at 12 o'clock. All right, good afternoon, everybody. Thank you for joining us today for our webinar on Energy Code Lessons Learned. Um, just a quick few housekeeping notes before we get started. We are offering continuing education credits for the webinar for the IECC and AIA. So if you want those credits, you'll be receiving a certificate of completion after the webinar for IECC. And if you need AIA continuing education credits, reply to that email when you receive that certificate with your member number, and we will take care of turning that in for your credits. As today is a panelist discussion with Don Ploss and Nelson Sostrom and myself on lessons learned for the Energy Code. If you have questions as we go along through our presentation, we want to essentially foster some discussion here. Enter your questions in the question and answer window. That will help us keep better track of what we've commented on and what we may have missed and need to catch up to. So if you do happen to enter comments in the chat window, we may miss those. So if you hover at the top center or bottom center of your screen, you should see a Q&A window. Enter your questions there for us, and we will address those with our panelists today. The things we're going to kind of cover as we move through this presentation, we're going to be discussing a little bit about the Commercial Energy Code compliance documentation best practices that we've run across in the field. And we're going to touch a bit on what we've seen in the commercial field that we'd like to see kind of tied into the residential energy code as well for driving better compliance with residential construction. And then we'll learn about some common errors in residential energy code compliance errors with site visits and how to ensure that you're not going to be having callbacks with your code official and getting essentially first pass compliance there. So the Smart Energy Design Assistance Center is an applied research program at the University of Illinois. Um, our mission here is to reduce the energy footprint of Illinois and beyond. And the Energy Codes program is one part of that process. Today's training is sponsored by the Illinois State Energy Office through the Illinois Environmental Protection Agency, and we would like to thank them for that sponsorship. The SEDAC Energy Codes program does offer Energy Codes technical support. We have an email address, energycode@sedac.org, and we have a 1-800 number there on the screen. Please feel free to reach out to us at those contacts. We do prefer emails. That gives us time to address your question in depth. So if you call in, specify whether your project is residential or commercial construction so that it can refer to the proper part of the codes. We'll discuss amongst our team, give you the best answer possible. We also have a wide array of online resources at sedac.org/energy-code. That includes past workshops and webinars, recordings of those workshops and webinars, self-paced online courses, and links to our technical support contact information. We also have quick links to the IECC website with the most up-to-date conservation code manuals. We also have links to frequently asked questions and answers and other useful websites, including the Illinois amendments to the Energy Conservation Code and the Chicago Energy Code. We also have, as part of our trainings this year, some upcoming webinars, Advancing Code Compliance. This is part of that webinar series. Coming up later in March, we will be having a commercial lighting plan review and site inspection presentation. And then in May, we'll be discussing commercial HVAC plan review and site inspection. We also have a series of workshops coming up. You can see those listed on the screen. The next workshop will be in March, addressing residential site inspection kind of in detail, a little bit more than we'll touch on today. So to introduce today's guest speakers, we have today with us Don Ploss from HR Green. He is an energy code consultant, and Nelson Sostrom from the City of Rockford Building Codes Office. They will be addressing most of your questions and answers today, while I'll be facilitating that discussion. Don and Nelson, would you like to go ahead and introduce yourselves in a bit more detail?
Well, good morning, good afternoon, I should say. This is Don Ploss. I'm retired from municipal service, so 20 years of service. My last 15 years was at Hoffman Estates. I was a director of code enforcement. And I've moved on through training and teaching codes, fire codes, all the other different codes across the eastern part of the states here. And right now I'm with HR Green, a third-party consultant who works with several of the northern municipal areas up here, the jurisdictions. And I am ICC Energy Sustainability Professional, Lead AP, and I've been very much into energy for the last 15 years, probably.
Thanks, Don. I'm Nelson Shellstrom, the building code official for the city of Rockford. My background is really coming from out in the trades, spent over 30 some years in the trades as general contractor, mechanical contractor. My first building inspection experience came from another contract building inspection services company in Northern Illinois, not the one Don works for. And for the last little over 5 years, been working with the city of Rockford as building inspector and now the code official for the city of Rockford.
All right, thank you very much. Thank you for joining us today. So our first topic we wanted to get into and open up for a little bit of discussion is commercial compliance best practices. In previous presentations that SEDAC has been offering this year, where we've been trying to raise awareness of code compliance and best practices, we've actually showed these examples before. This is an example of a lighting plan diagram, and off to the side they've included the lighting counts, what the wattages are, and showing the energy code compliance on screen there in the bottom right corner, where they've calculated out the applicable wattage for the different systems in the building, and that is within their allowable wattage budget to meet code compliance. This example comes from the New York City's building office department. They have a manual that shows a lot of examples of code compliance documentation. In discussing beforehand with Don and Nelson about examples of documentation compliance, we've commented on the resources at the New York City where they provide these examples are probably one of the better resources out there for finding good examples of documentation compliance. We have another example here of just envelope wall assembly where they've done the U value calculation, and again showing what their calculated UA is, what they're allowed per the code, and just showing, you know, right there on the plan drawings, it's documented in one place, easy to see. I don't know, Nelson and Don, if you wanted to discuss a little more in detail some examples where you've seen this on projects that you've worked on, or some further examples. If anyone else in the audience has questions about, you know, what should you be including on your plan documents to try to help these code officials process materials faster and more accurately. So what we're really looking to show here are examples of things that are going to, you know, reduce callbacks for information and save time in that code compliance documentation process.
A lot of times on these drawings, the challenges come where floors intersect, and make sure the envelope is complete around those intersections. One of the constant challenges is where you got a slab and hitting the outside wall, and how that thermal barrier continues along the outside of the perimeter of the building. So constantly working with architects, trying to get them to figure out how to make that fit in their design, whether that insulation is either inside the foundation or outside of the foundation, and how they handle that. So that is often a challenging part of the plan review, getting through that little intersection.
And follow up there, Nelson, with the exterior, when they do the foundation exterior insulation, to make sure that insulation is covered. I like to look at it on the plan is to see how they plan to make the covering, so the UV, and also some of the landscapers come along with the weed whackers and cut them off. So that's a big thing. That's one time I will ask detail for it on the plan review.
And another thing we wanted to touch on is, since a lot of our commercial projects that we see are going through a COMcheck process with a UA trade-off, I did want to touch on, Nelson had supplied this example of an automotive service facility where they had documented on the COMcheck report, they'd made good use of those comments and assumptions section of that report to enter in where to find values for compliance there. In this particular instance, we're looking at the envelope. They've noted, you know, on the plan drawings, they've got an envelope assemblies table that summarizes those U values and factors, and where they've shown that compliance.
And Nelson has really shown a good plan for COMcheck on this one here, because the engineer has taken the time to actually go through the comment and assumptions and actually put something in there where many times you'll get the envelope compliance certificate. They'll put the all the inspections in the back like this, but it'll all just say requirement will be met. So it's much better when like Nelson has shown here, that you actually see the envelope assembly, see this, so they tell you where it is.
Are there any particular areas in these reports where finding that documentation is particularly difficult, where these notes would be beneficial for you more so than any other areas.
Particularly in large plan sets. If you got 100 pages and you need to dig through to find it, that can be pretty challenging. So when the architect does you the favor of actually pointing to things, that's very, very helpful and saves us having to ask the questions.
All right. The next discussion point we wanted to move into was kind of the commercial energy code process and where we might. We did have a question come in. Richard Ang asked, do we still need to include envelope or lighting calcs in the drawings even if you have a COMcheck or rescheck submitted? Where the COMcheck and rescheck, they do those calculations for you for the envelope and lighting. Do you still want to see that kind of summary table in the plan drawings as well? Or is that COMcheck summary report all that you would need for compliance?
For myself, I'll look at the envelope compliance. I'll look at the mechanical compliance. I'll look at the lighting compliance and the exterior lighting compliance. And generally speaking, when I've got all of that, I don't expect to see that on the actual plan, the construction document itself. But it could be just as easy for them to put it onto it. Biggest thing I'm looking for is if it's actually there.
And we did have another question regarding interior wall insulation. This is particularly addressing interior foundation insulation. What's the purpose of the tapered cut at the top of the foundation wall? For insulation, we've seen that when it's installed on the interior to allow the concrete slab to reach out to the wall assembly. And that allows for insulation of flooring finish surfaces without having to cover the insulation gap between the foundation wall and the edge of the slab. We've also found that a lot of contractors are moving away from that because that concrete edge tends to crack as it's thin there where that slab or that insulation is sloped.
Yeah, you're right though, Sean. That's typically the reason why that bevel is on there, just to allow them to get their floor covering to the outside wall. So there's better ways to design around that, but if that's the only way they can get there, that's what they typically do. We see it fairly often.
Okay, and then we had a question about ASHRAE 90.1's trade-off method. If using the ASHRAE 90.1 trade-off method, is foundation insulation required if the COMcheck report passes without it?
If they can pass without it, they pass without it. It's nice to have it, but if they're doing their trade-offs, there are occasions where they can possibly get past it.
All right. Well, then moving on into our discussion about the energy residential part of the energy code. On the commercial side, we see a lot of designs and stuff where the architecture firms are designing to code regardless of the municipality's code they're working in. They're generally designing towards the most current energy code just to save them the work on having to look up various different codes and things. If they're working to the most current code, then they are also going to be in compliance with older codes generally. And what we don't see with residential, since they're usually the contractors are in local municipalities, they don't generally spread out enough to have wide access to different code variants. They tend to design to the local code that is being enforced. And so we tend to see with inspections on site that builders aren't designing to the current energy code in the state. And so that tends to lead to a lot of callbacks and wasted time with the builders and training them and bringing them up to the current knowledge base on the current energy codes. What we wanted to discuss were some of the ways where we can adjust around trying to bring that information to builders and designers where they can be aware of the codes and build in that compliance early in design so that it then trickles down into the construction of the home. Some of the examples that I've run across in research of good ways to kind of promote that design process was tapping into the home energy rater industry. North Carolina has a partnership with their raters where they are actually the energy code compliance officials. They work in partnership with the building offices. Since they're doing the testing for blower doors and duct leakage already, they're now also using them to assist with that energy code compliance documentation as well. And there's also a list of states at the bottom of the slide here where those HERS ratings are actually incorporated into the state energy code. Where in Illinois, the ERI, the Energy Rating Index, is the only place where you might get a HERS rater involved in the code compliance process. So there's a couple of ways that we've found where they've really been trying to build in that process of code design from the start of the design process and let it trickle down into the construction of homes, kind of like we see with the commercial side for compliance. Nelson, I know we had discussed in detail a little bit training opportunities, and Don, we've discussed that too, but reaching out to home building associations and hosting training sessions with them to inform them about the code, the benefits of compliance. Did you have any comments you wish to express on that kind of outreach and training that you would like to see on the residential side?
For us, it's really been helpful to partner with you, Sean, and your staff. As pretty much a larger municipality here in North Central Illinois, we've kind of taken the mantle of being the trainer for a lot of the design professionals and the contractors in our area, as well as other building inspectors and code officials for around the area. Prior to COVID, we used to host on-site training and invite different municipalities as well as design professionals and builders to come in for training sessions. Again, Sean, your staff was part of that, and we've had other people in to help us do that. So that's a huge help. Hopefully we'll get back to that again as COVID restrictions start lightening up again. But just reaching out to the people that are pulling your permits, the design professionals, the contractors, say, hey, here's what's going on. There's some new stuff in the code you should probably know, and we invite them in. So that's what we try to do anyhow.
That's really for myself. When I was in Hoffman Estates, we'd always every year have where we would pull all the builders in from the area, whether they were the tract builders or if they were just a once a year builder, and go over and try and go through the code and let them know that we're here to help. We're not here to tear their house apart, but we're here to be able to help you get something that's solid for the home owner that's going to last for a long time. It's going to be there. And then when I moved on after I retired, then I moved to different municipalities with HR Green, and I'd always have every year in the spring of the year, we'd have Building Safety Week, and we'd put that together with energy to make sure that even if the same builders were there the year before, that they didn't forget anything. So we would keep them so it would work out. And it really works out better for the builder, because if they have whys a lot of times are answered, and they would be able to provide a much better product for the homeowner that way. And that's all that the code officials out there to do, is to just make sure that it does look good, it is finished, and when the homeowner comes in, they're going to have something that's going to be there 30, 40 years and not have a problem with it. But getting the homeowner involved, I think, is a good idea too, if you can get those. And that's when we were in most of the places I've been in, I've done the teaching like that, whether it's New Lenox or DeKalb or whatever. We would invite the homeowners in the area also to be able to come in, or potential homeowners, so they would understand, because there's so many of the homeowners, they buy a house and they have no idea that there was an energy code also that went along with the mechanical code and the building code and the residential code. So with them being educated a little better, they can ask questions when they actually do go to buy a home, or whether they're having even additions put on, so they understand what the energy construction part of it should be.
We did have a couple more questions come back in regarding the earlier comment on foundation insulation. We had a question, what are some of the problems that you've seen when people using the trade-off to avoid foundation insulation or continuous wall insulation? What issues have arisen from that that you've seen in past projects?
Well, in practicality, I just don't like to see it. The code will allow it, but in practicality, you wind up with cold floors, and you have areas that are not conditioned as well as others. So that's the biggest problem that I've seen, I've experienced.
I'd have to go along with Nelson on that. In our area here, Northern Illinois, it gets pretty cold, so that can make a difference in the insulation when we're in area 4, area 5 up here. They are allowed, and it's part of the code, but it's still it will.
I know
I often tell designers that the building code is, if you pass the code, you now have a D in the class. You've passed, but that's it.
Mm-hmm. And I know we've seen with older buildings where, they were built to older codes that didn't quite require the continuous insulation or the foundation insulation yet, where we've seen frost damage to those foundation walls, where that concrete starts to break apart and crack a little bit because of moisture soaks into that material without insulation in place, that then freezes and expands, and that contributes to building damage. We had a question come in as well. Are there examples of better ways to install perimeter insulation on the inside so that there isn't that gap or that 45-degree angle on the insulation that you've run across?
If you look at the commentary actually gives you some suggestions and ways to work, and I believe there's actually some drawings in the commentary as well. So that'd be a good resource to look to.
And then we've run across in building, we're working on a publication on foundation walls. I think we've actually already published it, that addresses, you can kind of cantilever your interior wall over that insulation to cover that gap. You can use floor finishes such as like hardwood or something to cover that gap as well. So there are definitely options out there that'll allow you to seal that gap in without having to worry about that, leaving an insulation gap there or having that 45-degree angle that weakens the edge of that slab. We did have another question come into the chat real quick. Curious if either of the presenters or SEDAC have ever developed checklists that list all the mandatory provisions first and prescriptive provisions second, broken down by groups, building envelope, mechanical system, etc. And if they were willing to share those checklists. And actually, on our next slide here, we have the residential checklist for the Rockford Building Department that has those prescriptive requirements. And SEDAC is also working on developing a checklist that can be used that'll cover the prescriptive requirements, and then depending on the compliance path you're choosing, we'll also then select the different requirements through that check sheet as far as, COMcheck reports to submit or rescheck reports to submit. Don, have you run across any other locations that have checklists that kind of help with that first pass compliance?
No, I really haven't. The only thing you can use for the back of a COMcheck for the 11 sheets or so that come with it, there's pretty much a checklist for all the different sections, and each section is called out as it goes. But otherwise, no, I have never really run here in Illinois to anybody that's put anything like that together, except out. And I applaud out there at Rockford. This is a very good checklist. And Rockford has always been a leader here in energy code in the state of Illinois, and they continue that. Way to go, Nelson.
Well, I won't take the credit, but I'll I'll hand it off to my staff, who does an awesome job of getting compliance. I saw the question of where you can access. This is actually on our website, the rockfordil.gov, rockfordil.gov website. If you search in the Construction Development Services tab and look for permits, you'll find this form. And again, we're Area 5, so that's where these numbers are coming from. If you're 4 or 3 or whatever zone, those numbers not going to be the same. But certainly, if you want to take that form, edit it, and make it work for you guys, absolutely, you're more than welcome to dig in our website. It's a digital copy, so you should be able to pull it down and amend it however you need to.
We actually have posted that link in the chat window. So if you scroll back up through the chat, it will be in there. And we'll post the link again at the end, so it'll appear multiple times. We had a question about a commercial project in Ohio where the existing code doesn't allow substitution of an air curtain for a vestibule. The new code in ASHRAE allows that, but hasn't been adopted by the jurisdiction yet. Should one apply for a variance?
Well, in Illinois, we're set that whatever it says in the code book there, that's how it is. We have amendments that we do, and I'm on the Illinois Energy Conservation Code Advisory Council ever since 2004. I represent code officials. And every time we have a new energy code come out every 3 years, we have 18 months from the publication date to have the amendments submitted, discussed in different committees, brought back to the Capital Development Board, and then the Capital Development Board would decide if it would be approved or not. So as far as it goes in Ohio, I'm not sure how they run it through there, but I certainly, as a code official, I would be welcome to a variation. I have no idea why they would not go with the air curtain as a part of the vestibule. But that's about, I would say a variation would be good to submit. Yeah, you don't know if you're going to be able to get it or not, but at least you ask for it.
Yes, everyone can handle it differently, but I don't like the semantics of a variance. A variance is what I look at is for my zoning staff. If I want a taller fence or want to be closer to the lot line, I consider that a variance. When it comes to the building code, what I'm looking for, or looking for someone to ask me, is an equivalency. If I have an equivalency, I can back that up in the code. As a code official, I can say, yes, that's an equivalent means of achieving the requirement of the code. But I guess that's just a semantic game that I play. I don't like the word variance when it comes to building code.
We did have a question on, can you go over re-roofing insulation requirements per the Illinois energy codes? I know we get this question a lot, and we have an FAQ on it. Don and Nelson, you want to take a first stab at it?
Well, I'll tell you, the Illinois Energy Conservation Code Advisory Council spent probably, of the 18 months, we probably spent 14 months on talking about this and how we we're going to come up with some type of wording in the code on this. If you could go, now they're leaving the roofing on and they're going to go over it again. I didn't quite fit that one in there. Is it in a chat or is it a question?
It was a question that came in.
Okay.
But I know for existing buildings, if you're doing a re-roofing project for an existing building, there is an Illinois amendment that allows for a essentially a peel and replace project where you can peel off the old liner as long as you do not touch the roof decking or the insulation. All you do is peel off the liner and replace a new one over top of it. That is allowed. And you can find that that FAQ at our website. I think Jane will be able to post a link to that in our chat window here in a moment.
Well, we did come up at the end over there. We actually came up with a title for the roofing material. We called it a weather resistive barrier. And if they could remove the weather resistive barrier on an existing structure there, and if the insulation was intact, it was not wet, it was not ruined, you could go over and recover over it at that point with another weather resistive material in there. I know that we went back and forth a lot with the with architects and with roofing contractors. Chicago Roofing Contractors Association was a big input on that. And they were concerned about, you know, we have penthouses, we have all kinds of rooftop units up there, exhaust fans and everything. And it was all designed for like 1970. You didn't have the thicker insulation back then, you know, just had Fesco board basically back then. And if you went ahead and you put in the full required amount of insulation on top of it for a re-roof, your flashings could be a problem. Your doors on your penthouses and even your curbing around your RTUs up there could be a problem in there. So there is as Sean, as you mentioned, in our amendments, we've covered that, and I think you do have it in your facts. So there has been a lot of talk on this, and there's been discussion, and I'm sure when we get the 2021 code going in here, we'll come up with more discussion on it.
Let me just tag onto something Don mentioned, the Chicago Roofing Contractors Association. Earlier, we were talking about training. They have some fantastic training. Normally it's in person. This year, obviously, it was not. It was virtual, and I think some of that's still coming up. But for code officials or just building inspectors, whatever, that need ICC certifications, that is a great place to get some free certifications and some fantastic training. They really, really have some good stuff going on. So check out Chicago Roofing Contractors Association, their website, and they have some great information and just a neat organization.
I did want to touch on too, the existing buildings portion of the code does state that when you're working with an existing building system, you can insulate to the value that will fit within the given constraints. So as Don mentioned, where you've got HVAC systems on roof curbs or parapet walls or flashings that are limiting the height and depth of insulation you can install on that roof, you go back and install the maximum that you can without having to adjust those other systems. And that is code compliant. There's no request for equivalency or anything. For an existing building, that is code compliant.
And that's why we really went through it this last for the 2018 code. You know, there was a lot of buildings that they didn't want to put a re-roof on, or they didn't want to do anything because it would cost them money for this to be able to bring it up. So what they were doing is they were holding off on putting on re-roofing or patching and whatever, as opposed to a whole complete job. So we ended up with some problems with moisture getting in, and actually they were doing more damage to their building over there. So I think we made it pretty clear on this last 2018, and it had been for every edition prior about it. but I think existing buildings are pretty well covered now in the state of Illinois. And the intention is we want to get the best insulation, but we also want, there's affordability. Affordability was written into the International Code Council for the first time. When they started back in 2000, we are a minimum code. All of the different ICC codes are all a minimum code. I used to get a kick about the carpenters had on I-55 going south. They had a big sign that says, "We build to the code." Well, they build the minimum that they can, I guess. But it's very important that the affordability is there. We don't want it to be cheap, but we want to be able to make sure that they have a product that's the best that they can, the best insulation they can. You know, it's even like when you talk about with an existing residence that they open up, they're putting on an addition on the back. The addition by itself has to meet the 2018 code. But now they start to go onto the inside and they open up a wall in the kitchen area or something, and there's no insulation there. Well, you put the best insulation you can. You don't try and put in a 2x4 wall. You don't try and press in R19 into it because it's not going to work. You're just not going to get that good insulation in there. They may think they're getting better on it, but it's not. When you compress that bat, it's going to be it's actually inferior at that point. So you try and do the best you can. If there's insulation in the wall, the way the code reads is that you just leave it and you put the drywall up and you're done. Or even if, let's say, you pull a roof off and you pull your asphalt shingles off, you pull the sheathing off of the residential up there, and you look down and there's no insulation in there at all in the joist there, the floor joist in there. Now you're going to have to go in, because you've seen it. Now you're going to have to go in and you have to insulate that. If you pull the shingles off and you do a re-roof and you don't, you're not looking for it down in there, you don't have to put it in. But if you open it up and discover it, it has to be to the best you can do.
We did have a question come in regarding the COVID situation. With COVID still impacting our lives, is there any concern about sick building syndrome in relation to how building gaps are being eliminated to meet the energy code? Or would this type of syndrome be attributed to how the mechanical systems operate?
Well, you know, this can be the way we got these houses more closed up. They used to just talk about a little bit about caulking in the code. Today, what we do is we actually have it so we go around and, we're going to talk, I thought, a little about air barriers here in a little bit. We're going to talk about how it's sealed up. Once you seal that house up, you could take a mason jar, clean that mason jar out completely, put a cap on it, put it out on the picnic table in the lunchtime out there. And within about 20 minutes, you're going to start to see condensation inside that jar because it's trapped inside. And a lot of times, if you don't build your house correctly, you're going to have that trapped moisture inside also. And that does get to, whether it's COVID or if it's just to have a healthy house with mold or any problems like that. What we have done is when we close the house up, we're looking for, when we do go to the blower door, which we'll get into a little bit too, but you close the house up, you need to have some type of outside air into it. When I was in Hoffman Estates, we actually did, we had all the equipment to do air changes. We could do a whole house review by ourselves over there. We had the blower door, the equipment, the duct blaster. And when we finished up doing a report for a homeowner, we tell them that the house is too tight. They've done a good job. They've tightened everything up on the second time. They've tightened everything up. But now we're telling them to put a hole in the wall. They say, why a hole in the wall? Well, because we need to have exterior air, which is going to complement your house and be able to do it. But we need to control it. We just don't have gaps around the windows, around the doors, at the floor, at the attic hatch, whatever. those are uncontrolled areas where you get air and infiltration into it. Around the rim joist, that's probably a perfect place. The electrical panel, the cables that come into your electrical panel, your even your sump pit down there, if you don't have it covered out and your close off on that, on top of it, covers on the holes, you're going to get air infiltration into your house, which you do not know where it all comes from. You might have an air change of 11 per hour or something, and you get it down to 5, but now you need to put that exterior in there. And a lot of the builders, what they'll do is they'll use the return ductwork, and they'll go to the end of the ductwork, and they'll end up going out to an exterior hole, and they can have either a Honeywell type of a flapper valve in there to be able to make the amount of air goes into the cold air return. It's tempered by the time it gets to the heat exchanger, and also it's nice and it'll be warmed up and everything. So you'd have outdoor air at that point where it's bringing it in, and it's making it so the house is friendly for an environment. You can get a house too tight, and you can get a house that's very sick from that.
We did have someone post an analogy in the chat: breathe through your nose and mouth, not through your skin. It's a really good analogy for building systems. So yeah, buildings are getting tighter and tighter, but you want them to breathe through the mechanical system where you can precondition that air and send it into spaces where it's not going to be causing comfort problems. You're not going to have humidity problems. You're not going to have condensation issues within your wall assemblies. So it's we haven't seen a lot of concern about sick building syndrome from buildings being tighter yet, because the code also has built in those mechanical ventilation requirements. We did have one more question, and we'll get into our residential site inspection things next here after this question. But have either panelist been involved in a project where the building envelope assembly had condensation within the assembly due to the design and layers of that assembly? Had anyone put vapor barriers on the inside and outside of the wall and trap moisture inside of it?
I'll just go real quick there, Nelson. Wilkins Insulation, George Wilkins, back in the 70s, he had to have, there was architects who thought they were getting things better and better as they go, and they'd have the outside wall, and then they'd build another 2x6 interior wall, and they'd have a vapor barrier on each of the walls as they go along. And that is the worst that you can do, because you end up with that mason jar effect, with that the backside of that plastic, and a lot of them were using the plastic, and it would just roll down. And today I haven't seen much of that, but the biggest thing is in this area here, the vapor barrier is to go onto the warm side of the wall itself. And if you do it that way and you follow through, you really are okay. But you do a double vapor barrier, you're going to have a lot of problems with moisture in there.
Yeah, I concur. I've seen the same thing done over the years. Boy, just getting the vapor barrier in the wrong location somewhere, creating a dew point inside the wall, and you wind up rotting out walls. It's problematic. I think there's an awful lot of people out there who don't realize that if you have latex paint on your drywall wall, your latex paint is your vapor barrier. My personal feelings, I don't like seeing visqueen on outside walls, but the code allows it. But yeah, get your latex paint on your drywall and you're good to go. You're 100%. And at that point, the vapor barrier is on the warm side. There's no question. It's not inside the wall somewhere.
All right, we got a couple questions. We'll get to those at the end. We do want to touch on our residential site inspection materials here real quick. Just kind of what do you need to know to pass that first site inspection so you don't have callbacks, you're not expending that time to have the code official come back out and re-verify corrected details. So we wanted to go through just some examples of common issues that we've run across. And Don and Nelson, as I go through these pictures, if you want to offer up some comments or past examples where you've seen these yourselves. probably the one that I have seen the most is not continuing the drywall down behind tubs and basins on exterior walls. That's kind of why I put this one first. With that tub assembly being open to the wall cavity on the exterior wall, since it's hollow underneath, that opens up a bunch of interior wall cavities now to any air leakage that comes into that outside wall. So it's very important to have that continuous air barrier all the way down the exterior wall that isolates that volume around the tub basin from that exterior wall cavity. And the other thing I've run across is with face stapling insulation. That face stapling covers up a lot of issues with the insulation detail behind that paper. So when I was doing residential inspections, I would always spot check, pull open that face stapling in a couple of places where I saw wires coming out through the top plate or something like that, and check to make sure, did they split the insulation properly around the wires or the plumbing? Did that insulation actually fill that cavity all the way? So important to catch those little details.
You know, and Sean, that's great that you pull in for the full air barrier behind the tubs or showers, whatever it is, when you're on an exterior wall out there. You know, it's still, if somebody's just building new in here, they probably wouldn't think about that. We put the insulation in there, but they want the air barrier there for a reason. The other part is you talk about with the your second one there is you have the wire in there, and you haven't cut around it. Well, we have conduit almost everywhere here in Illinois, northern Illinois, and the boxes that we have. And if you go in for an insulation inspection, you're going to see that the insulation many times they'll put it behind the vapor retarder. There gets put behind the 1900 box. And so what you've got, that 3.5 or 3 5/8, whatever insulation you have, is now compressed down to an inch and a half out there. The way the instructions come from either Johns Manville or any of the Owens Corning is you're to be able to split the insulation like you do the conduit, how you're coming down. And when you get to the box itself, you're supposed to open up and just open up that enough so you get the vapor barrier there so you could get the insulation behind and around it. So it takes more time to do it correctly, but just pushing that insulation behind the 1900 box does not make it for code compliance.
Next things we wanted to touch on were rim joist penetrations, and Don had just mentioned this before with line sets for your AC units, the utility box where you got your main electrical lines coming through. In this particular instance, they had fiberglass bat in this rim joist, which is also poor practice. You want to have that continuous insulation in there that's not an air permeable insulation, so you don't have condensation forming on that rim board. But also making sure that, you know, if someone goes into your home's envelope and drills a hole through, you want to make sure that those holes get sealed back up. A lot of builders now are using California corners. It's not too common to see traditional corners like this image in the middle, but making sure that those corners are completely filled with insulation. I've run across the California corners where they've, you know, stuffed insulation in the front and not actually stuffed it back into that corner. And so you end up with a cold corner there. And you can actually end up with issues with condensation and stuff in those corners if those aren't insulated properly. And then the last thing I wanted to touch on, since a lot of builders now are using spray foams as their air control layer, getting the proper depth of that insulation to ensure that you are in compliance with the air barrier material. With open foam, that's going to be that 4.5 to 5.5 inches of foam is going to qualify as an air barrier. And with closed cell, it's going to be that 1.5 inches or so. Don or Nelson, did you run across any of these common issues, particularly with spray foam insulation? I've heard a lot of comments about spray foam insulation.
Of course, challenging spots you always run into is where soffits hit walls or cantilevers. Those are always, there we go. Those are always challenging spots to get properly insulated. Most of our residential wind up being done by local insulation contractors. So been a lot lot of education between them and my inspection staff, but those are challenges. Trying to figure out where those questionable spots are going to be based on the design of the home.
Another one that I've run across a lot is that attic access hatch in homes. I've been in a lot of older homes where you open that access hatch and all the insulation falls down on your head. So making sure that, not only that you have those retaining walls in place to hold that in place, but this needs to have an air barrier, air seal on it. You need some weather stripping on there, something that latches that door in place so you've got a good air seal. You're not going to have your home's air wafting up through that access hatch and then condensing on the inside of that, causing mold and deterioration of those materials. Another thing very common to run across, top plates on vaulted ceilings. You can see here you've got a normal kind of flat wall top plate here on the outside of this left-hand image, but then you've got a vaulted ceiling coming down, and there's no top plate for this wall assembly. So this corner wall cavity here is actually open to the attic space above this vault. So that whole section of the wall there is going to end up being a cold cavity or a hot cavity and causing comfort issues. So making sure that as you're going through, checking those details and making sure that you've got continuity of the air barrier for those assemblies. The next picture over is actually, this is a partition wall between a garage, unconditioned garage, and the interior space. And you can see at the top, they took the floor insulation for that bonus room, took it over to the top plate, and then just curled it down to the top of the top plate and didn't put any air block in there. So very important to make sure that those are sealed off properly, particularly with garages for indoor air quality. You don't want combustion fumes from the garage being able to enter the house. And then lastly, some things on ventilation. Exhaust fans, you want to make sure so that your exhaust fan is actually going to meet its design airflow, that you're going to have as short as possible and as straight as possible exhaust duct coming out of that exhaust fan straight to the outside wall. Every time you put a kink or a curve in that extends the duct's effective length, adds frictional loss to it, and you could end up with a situation where that exhaust fan isn't moving the airflow that it's required to move or designed to move. The other thing to be aware of with flex ducts, making sure you don't have sharp kinks and things that are going to restrict airflow in that ductwork. So a couple of things to consider there for ventilation. We've had a couple more questions come in. We've got one here. When introducing outside air into a furnace unit or return duct, what volume of air should it be designed to, and how much does one control that volume? I believe we've had questions before where they've asked, intermittent exhaust fan use for like a kitchen hood or a restroom, does that get included and have to be adjusted for with that mechanical ventilation, or is there a fixed design volume?
Well, I'll take a shot at that one. When you're introducing the air into the furnace, I don't know of any mechanical engineer that's talked to me about it as what it should be. Generally speaking, it's about a 6-inch duct that comes in from the outside. Honeywell has the flapper damper there that can, when the furnace comes on, it opens up and it allows it in. And I'm not quite sure how, I'm not a mechanical engineer, so I can't on that. But that's one way to do it. And the other way is really just to have a fan. Panasonic has a very good fan right now that's very quiet and it works. But, a lot of people will, the fan's running, they don't know why it's running. They may not have been educated, so they turn it off. So now we got a house that's really totally closed up. So there's nothing is, I guess, idiot proof or whatever, but I don't know of anyone that's ever talked to me about what the volume, how much it is, and how it's figured out. Nelson, maybe you have an idea on that one?
I don't get directly involved. My mechanical inspector actually handles that for us. But there are specific design criterion as far as what the volume needs to be based on the space of the building, the square foot of the building. And in essence, it's reaching toward that 5 air changes that's required by the energy code. And that's how, as I understand, that's how it gets calculated out.
Yeah, so on the residential side, it directs back towards, I just had it looked up here, the International Regional Code or the International Mechanical Code. And for those, it's a fixed volume of air per square foot of space and per occupant, which is based on number of rooms plus one person. And for commercial buildings, it's ASHRAE 62.2. And those are fixed volumes that need to be ventilated for. So you're going to kind of negate any variable exhaust that's in the house, assuming that that pressure imbalance is going to be taken care of by leaks through the envelope. And you're really designing, sorry, commercial building 62.1, I said 62.2. But your variable exhaust is in general going to be taken up by leakage through the envelope, and you're going to be ventilating to that fixed volume that's in the International Mechanical Codes or the ASHRAE ventilation manuals.
And actually, we did take that because the state of Illinois does not have a state code, but we have a state energy code. So not everyone's going to have the International Residential Code as their code for their municipality. So I think in the 2009 version or the 2012 version, we actually took that table from the IMC and looked at ASHRAE, and we put it into as an amendment into the Illinois Energy Conservation Code. So it is in the amendments.
Mm-hmm. We did have a question. How do you lap the weather barrier at the wall and the air barrier at the ceiling for wood frame construction? So,
is that for the
bathroom
part, I would joint, think? Or?
It's the air barrier for the wall to ceiling joint. Kind of the best method to tie those together.
Follow instructions. I'm serious. If you're using Tyvek has on their website, they have instruction manuals or YouTube type things, and their instructions that they send out their printed instructions are very detailed. And some of the other air barriers, like the green board that they put up, that's an air barrier also. So you need to be able to follow that. If they tell you to tape it with this certain tape, that's what you have to use.
Nelson, do you have any follow-up, maybe for on the commercial side of buildings, tying together that wall and roof assembly?
That on commercial is really a challenge because typically you have your siding contractor or carpenter doing something in the exterior, and they're going to meet with the roofing contractor. I've seen way too many times where those two guys are not communicating effectively. Hopefully the design professional has laid out how that, particularly like a parapet wall cap, is meeting with the vapor retarder on the exterior of the building and how those are meeting. But inspectors really need to be in the loop on how that is happening and make sure those two different trades are communicating so it does become continuous. I've seen way too many instances where that becomes a point of condensation, and eventually the building owner is going to say, hey, my roof is leaking, when in fact it's not leaking. You're creating condensation and moisture is entering the building that way. So if those two trades are communicating effectively, you don't have that complaint to the roofing contractor a year or two down the road about a roof leak that doesn't exist.
Yeah, some of the details that I've run across for parapet walls, there's a couple different ways to do that. One where the parapet wall is essentially built on top of your, there's a connection for your thermal barrier and your weather resistant barriers, and the parapet wall is built on top of that. So it's not included inside the envelope since it is essentially just a detail above those. and that makes a much more effective connection between the wall and the roof. But I've also seen where, that roofing membrane goes up and under a flashing piece, a cap piece on top of the parapet wall, and then wraps around to the outside and connects to that your bulk water layer on the outside of that wall, to make that continuous joint all the way across that connection for your air and moisture barriers there. So there's a couple of ways to do that. The main thing is just making sure that you've got a solid connection across those, detailed in your drawings, so that the tradesmen, when they're actually putting it together, can communicate effectively and make that proper joint. Well, that is about brought us up to our time today. I want to thank everyone for joining us for our discussion. There's a lot of good questions today. I hope we were able to teach you something new. If you have any further questions for us, please do not hesitate to reach out to SEDAC, energycode@sedac.org. I'm sure Don and Nelson would be happy to answer any questions you have as well. And thank you all for joining us today. Hope you have a wonderful afternoon.
Thank you all.